Alrighty, this video covering basic stoichiometry, balancing equations, and how to find the molar mass of something. So, let's start with balancing equations. Balancing equations means getting an equal amount of the atoms on both sides. So if we have, that's not even a color. We'll do red. C3H8 plus space there plus space O2 to H2O and CO2. Now, what we do is obviously this is not balanced right now. So what we do is we take count of our carbons, our hydrogens, and our oxygens on both sides. So over here we have 3, and then 8, and then 2. Over here we have 1, 2, and 3. So, what should we do first? I think we should balance our carbons. So that means we would put a 3 here, which would bring our carbon count over on the right side up to 3, but it would also bring our oxygen count. It would double this, so it would be 6, 7. So 7. So now these two are good, but we have 8 hydrogens over here and 2 over here. So if we just do 4, then that would bring this to 8. Nat 8 would be good. And then since we now have 4 of the 4 times H2O, so that means 4 oxygen here and 6 oxygen here from 3 times 2. That means we have 4 plus 6 is 10. So now we have 10 and 2. We can't decrease these to get this down to 2, but what we can do is increase this 2 up to 10. So we'd have to do for that. Here, I'll put a little cross through the O's to make them look different than the zeros. So what we'd do over here is multiply this one by 5, which would multiply the 2, which would give us 10. Check. So that means this one remains a 1. Now, if we double check all our work, carbons, 1, 2, 3. Carbons, 1, 2, 3. Hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8. Oxygen, 2, 4, 6, 8, 10. 1, 2, 3, 4. 2, 4, 6. 4 plus 6 is 10. Check. This is now a balanced equation. So, now that we've got our balanced equation, and I wish I could make this eraser bigger, but I'll work with what it gives you. So, whoopsie daisy, I'll have to rewrite those. 3, C. There we go. Now that we have our balanced equation, let's find the molar mass for all of these parts. Now we'll label U blue, U purple, U green, U orange. So, to find the molar mass, you want to go to... Sorry, I just got that's a cool background. Sorry, I'm looking at my browser and I just found a cool background. Might have to add that later. Anyway, enough sidetracking. If you pull out your periodic table, or in my case, lovely PubChem. Love this website. And then trying to fill in the frame here. And then look for your periodic table. And then go over to the elements that you have. So for carbon, our atomic mass is, we'll just say 12. 12.01. So carbon equals 12.01. And then, where did it go? And hydrogens, it's just 1. So then hydrogen equals 1. So, since we have 3 carbons, we multiply 3 times, oh, come on, 3 times the 12.01, 12.01, what? 3 times, there we go, and we get 36.03, and then we add on 8 times 1, which is just 8, since we have 8 hydrogens, and hydrogen is 1. So, plus 8. So that means the molar mass of blue is 44.03 grams per mole. On to purple. Oxygen. Actually, oxygen's molar mass is, I think it's 16. Oh, whatever, that's close enough to 16. So 16. Now, do not multiply the 16 by 5. I know that 5 right there looks tempting, but remember, there are 10 oxygens here total, because the 5 times the 2. So you have to take 16 times 2, or, yeah, 16 times 2, times 2, and then multiply that by 5. So 160. Actually, no, you do not do that. I'm so sorry. That would be the molar mass for the total amount of these, but the molar mass for just one of those is just 16 times 2, because you have 2 right there. We can ignore the 5. I'm so sorry about that if that was confusing. Ignore the number in front. Only focus on the subscripts. So in this case, it'd be 16 times 2, which is 32. So 32 grams per mole. Now on to H2O. Now we already know that hydrogens is, what is hydrogen? 1. Since if we have 2 of those, add 2 to our oxygen of 16 plus 16, we get 18. So our grams per mole, 18 grams per mole. And then we just do the same thing for the carbon dioxide at the end, which is 3 carbons. So not 3 carbons. I got distracted by that 3. 1 carbon, 12.01, plus 2 oxygens, so 32. 44.01 grams per mole. There we go. That is the very basics of stoichiometry. Now, let's say we want to do a stoichiometry problem, figuring out how much, let's say, how many grams of carbon dioxide would be produced if we have a complete reaction of 2 moles of this, or if we just have a complete reaction with 2 moles of this. So that means we'd have 10 moles, or 10 of these, and 8 of these. But we could ignore that. So, first what we need to do is figure out the ratio between the 2 items that we know. So, in our equation, we know that blue will be a 2. This will be a 10. This will be an 8. And this will be, since we doubled this, and since we doubled this one, if we want a complete reaction, that means we have to double this as well and double this as well. So it means we have to double this last one as well. So 6. So that is how many moles of carbon dioxide we will get if we have a complete reaction with 2 moles of this. So now, to convert moles to grams, we multiply by the molar mass, which 44.01 times 6 equals, let's find out, times 6, 264 point, what was that? 06 grams. Now, here's a little trick that my teacher taught me. When you are going from moles to grams, to grams, remember, multiply. So you multiply by the molar mass. If you're going grams to moles, remember to divide by the molar mass. So, a little while ago, I did do a more in-depth video on stoichiometry, but this is just the basics of stoichiometry, how to balance an equation, how to find the molar mass of something, and then how to do a pretty basic stoichiometry problem of just finding the amount of grams produced from a complete reaction. But I'm sure if you do some searching on the channel, you'll be able to find the more in-depth video. Anyway, happy studying, good luck, and thank you for stopping by. Goodbye.